What's up everyone, Patrick here, welcome back. And in this next example, what we got to do, we got to take all these numbers here, we have to list them from the smallest to the largest. Now when it says from the smallest to the largest, another way you could think about this is from the most negative. If you think of a number line, so on a number line, the numbers that are most to the left to the largest, the most positive, all the way to the right of the number line, right? So this is going to be on the left, this is going to be on the right. Now notice how all of these, they're in different formats. And so sometimes what you're going to have to do is simplify these. So notice that like these absolute values, you can simplify. So this negative absolute value of negative pi, now we know pi is what, 3.14 approximately. Now negative 3.14, the absolute value of that is going to be positive 3.14, and then we have this negative here, so this would be negative 3.14, right? Or negative, this simplifies to negative pi. Then over here, we got the absolute value of negative root 8. Now root 8 is going to be approximately 2.8 if we round it to one decimal, and the absolute value of negative 2.8 is going to be positive 2.8, right? So this here simplifies to positive root 8, right? So sometimes when you have these absolute values, you can simplify them first, and then it can become a little bit easier to put these on a number line. So notice that we have a 0 as well, so we'll put the 0 over here. And then we can try to put everything in relation to that 0. So if we try to figure out what is the smallest number out of all of these, what we can do as well is we can put them all in the same format. So notice negative 6 over 5, that's going to be negative 1.2. Negative 2 pi, 3.14 times negative 2 is going to be negative 6.28. And then we have the 3 as is, negative 3.14. Now negative root 15, that's going to be approximately negative, the root 15, that's going to be approximately 3.9. Now if you don't have a calculator, if we got root 15, what you can do is you can think of this in relation to the closest rootable number. So root 15, and then if we have like root 9 and root 16. So root 9, that's a rootable number, that's 3. Root 16, that's 4. And then notice that root 15, it's closer to root 16, right? So we know it's going to be greater than 3.5. It's actually around 3.9. But again, if you don't have a calculator, that's how you could sort of approximate these. And so knowing this root 15, it's approximately 3.9, but then we have the negative in front, so it's going to be negative 3.9. And so now, and then same thing with the root 8. So root 8, the closest rootable numbers are what? It's in between which rootable numbers? Root 9 and then root 4. So we got 2, 3, and then notice that root 8, it's closer to root 9. So it's going to be greater than 2.5. It's going to be between 2.5 and 3. So it's going to be, again, approximately 2.8 if you rounded it to one decimal place with a calculator. So this is going to be positive 2.8. And so from here, we can rank these on the number line. Notice the most negative number is going to be this one, the negative 2 pi. So it's going to be negative 2 pi over here. And then we're going to have, the next one's going to be the negative root 15, right? The negative 3.9. Then we're going to have a negative pi, but let's keep it in that same format. So we'll have negative absolute value of negative pi. And then we'll have the negative 6 over 5. That's going to be over here, the negative 1.2. So let's cross out what we have got already. So we got this, and then all that's remaining is the 3 and the 2.8. right? And we know that root 8 is going to be less than root 9, which is going to be 3. And so we'll have root 8 over here, and then we'll have 3. Right, so we start off with 7 numbers, 1, 2, 3, 4, 5, 6, 7. Right, so that is the order, ranking them from smallest to largest.